Indonesia is a vast country composed of 17,506 islands, rich in natural resources. In the 1970s, the nation gradually advanced its economic development. The second five-year development plan, launched in 1973, focused on transportation, gradually shifting from general transportation infrastructure to the construction of expressways and railways. The fourth five-year development plan, implemented from 1983, prioritized power generation, followed by the development of industry, mining, and water resources. Retsair Engineering Agency entered the Indonesian engineering market and grew alongside the country's economic development, building a history of over 20 years. At the time, Retsair Engineering Agency's staff bravely took on the challenges of harsh jungles, swamps, and monsoon seasons. Through arduous efforts, they earned sincere friendship and high praise from both the Indonesian government and the public. The Retsair Engineering Agency office in Indonesia successfully carried out numerous major projects, including the reconstruction of the Sumatra Island North-South Highway, the Surabaya-Malang Expressway, the Raram Dam Reservoir, and civil works for the Cilegon cold rolling steel mill. These achievements reflect Retsair Engineering Agency's dedication to actively expanding its presence in the international engineering market. In February 1987, amid intense competition from 15 international firms, Retsair Engineering Agency's Indonesia office, in collaboration with a local contractor, secured the contract for the Bakaro Hydroelectric Power Plant project, commissioned by the state-owned electricity company in South Sulawesi Province. The Bakaro Hydroelectric Power Plant is located in Bakaro, along a tributary of the Sadong River and the lower reaches of the Mamasa River. The dam and water intake facilities are situated approximately 8 kilometers upstream from the plant. With a river flow of 40 cubic meters per second and a hydraulic head of 340 meters, the water is channeled through a 5,909-meter headrace tunnel and a 1,702-meter penstock to generate electricity at the powerhouse. Before construction officially began, advance teams actively worked on building workers' camps and opening up access roads. The project was launched simultaneously in several areas: the dam site, headrace tunnel, open-cut section of the penstock, and the power plant site. Construction officially commenced on April 15, 1987, with a scheduled duration of 3 years and 5 months. The total contract value was $34.2 million. To meet the massive concrete demands for the dam, tunnel, and power plant structures, the construction site was equipped with 1 quarry, 2 crushing plants, and 3 batching plants. The operation deployed 24 concrete mixer trucks, 9 concrete pump trucks, 30 dump trucks, and over 400 workers. These facilities and personnel were responsible for producing and delivering 280,000 cubic meters of concrete across the entire site. At peak performance, over 1,500 cubic meters could be placed in a single day, an enormous responsibility central to the success of the project. To improve geological conditions and ensure the safety of the dam foundation, extensive treatment was carried out on the bedrock surface. After manually removing weak geological materials, the area was high-pressure washed and backfilled with concrete to consolidate the rock into a unified structure. A cofferdam was completed on the right side of the dam site to divert the river flow, allowing construction to proceed within the original riverbed. Adjacent to the river, a 120-meter-long diversion channel was excavated. Once excavation was complete, the channel's surface was concreted, requiring a total volume of 4,380 cubic meters. On October 10, 1988, the diversion channel was completed and commissioned ahead of schedule. The water release ceremony was presided over by Mr. Sarjono, President-Director of the Indonesia's State Electricity Company, who pressed the button to initiate the official water flow. As colorful balloons floated skyward to the applause of distinguished guests, President Sarjono repeatedly praised Retsair Engineering Agency's tangible contributions to infrastructure development in Indonesia. The early completion of the dam's diversion channel, just before the onset of the local rainy season, not only mitigated potential risks and losses to the construction site but also enabled the early commencement of the dam's main structure. The dam was constructed in two sections, left and right banks, executed separately. After the successful completion of the diversion channel on the right bank, which effectively redirected river flow, work began on the main structure on the left bank. The two intake structures on the left bank were built in coordination with the dam construction, with the contractor dedicating full effort to the concrete placement. The design required a total of 25,000 cubic meters of concrete for the intake structures. The dam itself is a concrete gravity dam, standing 16.5 meters tall with a crest length of 92.5 meters. It consists of 7 pier columns, 2 abutments, and 8 gates, 4 floodgates, 2 sediment sluice gates, 2 water retention gates, and 2 regulating gates. To meet the project deadline, 24-hour round-the-clock shifts were adopted. At the construction peak, more than 600 workers were deployed. Deep within the mountainous terrain, the site was illuminated at night as brightly as daylight. As time passed, the dam gradually took shape. Spanning the Mimasa River, it covers a catchment area of 1,080 square kilometers and is capable of storing floodwaters for power generation. The electricity generated supplies households and industries across South Sulawesi province, from Bakaro through Pinrang and Perper to Makassar, covering several hundred square kilometers. The 5.9-kilometer-long headrace tunnel passes through numerous mountain interiors. To facilitate construction, 5 adits were initially opened in various valleys. Once the adits were completed, excavation of the main tunnel proceeded from both sides of each adit. To accelerate progress, the project was later expanded to 9 working faces operating simultaneously. Both the adits and the headrace tunnel were constructed using the new Austrian tunneling method. Handheld drills and modified drilling jumbos were used for drilling and blasting operations, with each blast advancing approximately 1.5 meters. Excavated debris was removed using mucking machines and tipper cars, transporting the material out of the tunnel. In sections with weak bedrock, steel mesh and rock bolts were added to enhance structural support, followed by shotcrete application to meet all engineering and safety standards. For the lining of the headrace tunnel, 3 sets of 9-meter-long self-propelled steel formwork and 1 12-meter-long set were employed. Additionally, a 6-meter-long steel formwork was used for lining the adit tunnels. Concrete was placed using a concrete pump, achieving 1-pass monolithic casting. After each pour, the concrete underwent curing for 6 to 8 hours, followed by the rebar tying work for the next segment. The formwork was then moved forward, and the next section of concrete was poured immediately. The excavation diameter of the tunnel was 5.3 meters, and after lining, the internal diameter was reduced to 4.5 meters. In addition to the headrace tunnel, other components of the project, including the dam, penstock, semi-underground power plant, and tailrace tunnel, were all constructed simultaneously. The construction team was required to carefully manage the progress of each element and complete them in accordance with the contract specifications for delivery to the client. To ensure tight joints between tunnel sections, drilling rigs were installed inside the tunnel to bore into the surrounding ground for 3 types of grouting: backfill, consolidation, and curtain grouting. These high-density grouts were intended to completely fill any foundation voids within the load-bearing zones. During grouting, detailed records of grout take were maintained to monitor effectiveness. The headrace tunnel, one of the most challenging components of the project, was completed thanks to the tireless efforts and perseverance of Retsair Engineering Agency's staff. It was fully bored through on June 22, 1989, 2 months ahead of schedule. The breakthrough ceremony was personally presided over by Indonesian Vice President Sudarmono, who came to the site and pressed the ceremonial button. The surge tank of the Bakaro hydroelectric power plant was designed to be 32 meters high with a diameter of 10 meters. Construction was carried out using a caisson-type method, excavating the full cross-section from top to bottom. After each round of controlled blasting and muck removal, rock bolts and shotcrete were applied immediately to stabilize the rock walls. To further consolidate the rock mass, grout pumps were used to inject cement grout into the bedding planes and fissures, ensuring complete filling and unifying the rock into a solid structure. The connection between the surge tank and the tunnel was established only after both the upper tunnel and the horizontal tunnel had been excavated and successfully linked. The concrete lining of the surge tank was carried out using timber formwork from the horizontal tunnel, followed by lift construction upward from the bottom of the surge tank. The total length of the penstock is 1,725 meters, consisting of 1,285 meters above ground and 440 meters underground. For the upper tunnel section of the penstock, preliminary kinetic stabilization works were first implemented to reinforce the tunnel entrance and ensure geological stability, serving as a safety measure before formal tunnel excavation commenced. The upper tunnel section measures 5.9 meters in height and 5.6 meters in width, housing a 4.4-meter diameter steel pipe. Constructed using the new Austrian tunneling method, the crew installed steel mesh and rock bolts, and injected grout to fill bedrock fissures, enhancing structural stability. The open-cut section of the penstock was excavated using a step-by-step blasting method, incorporating a specialized pre-splitting technique. Pre-measured explosive charges were bundled onto bamboo strips, which were then inserted into designated pre-split holes. Once all charges were loaded, blasting was carried out. The total excavation volume for this section exceeded 334,000 cubic meters. Structurally, the open-cut section included the construction of 11 large support piers for the penstock, spaced 120 to 140 meters apart. These large piers varied in size, 8 to 10 meters wide, 6 to 14 meters high, and 16 to 26 meters long. In addition, 55 small piers were built, spaced at intervals of 18 to 20 meters, with dimensions ranging from 2.3 to 4.6 meters in length, 5.7 to 6.4 meters in width, and 1.5 to 10 meters in height. Concrete surfacing was applied along the entire alignment, including slope protection works. In total, over 52,000 cubic meters of concrete were poured. Through the dedicated efforts of the construction team, most of the pier structures were completed on schedule and handed over in phases as specified in the contract for the installation of the penstock. The inclined shaft measured 170 meters in length with a steep gradient of 50 degrees and was lined with high-tensile steel pipe. Initial excavation was carried out using a full cross-section method from both the top and bottom work faces, advancing a total of 16 meters. Following this, custom-built scaffolding was used to simultaneously excavate 2-meter by 2-meter pilot tunnels from the top down and bottom up, progressing 1 meter at a time. Once the pilot tunnels were connected, full-section enlargement excavation was carried out from the upper end downward. Due to the steep incline and large excavation area, earthworks proved especially challenging. To ensure slope stability, retaining walls were constructed on both sides of the steel pipe, an essential aspect of the construction process. From a distance, the penstock section resembled a massive crouching dragon, a vivid testament to the immense scale and majestic engineering of the project. The power plant is located on a cliff within the deep gorge along the lower reaches of the Mimasa River. During construction, extensive slope excavation was required, starting from an elevation of approximately 370 meters and progressing downward. The total volume of earth and rock excavated exceeded 166,000 cubic meters, including over 36,600 cubic meters for the power plant foundation alone, a massive undertaking that necessitated stepwise excavation. The construction team adopted a benching method, excavating downward in 10-meter vertical increments. At each level, steel mesh and shotcrete were applied to stabilize the slope, along with the installation of drainage systems and retaining walls. These measures were critical to protecting the site from flash floods during the rainy season, ensuring the safety and continuity of construction activities. The power plant building measures 70 meters in length, 36 meters in height, and 38 meters in width. Its foundation extends 16 meters below the riverbed and adopts a semi-underground reinforced concrete structure. Due to the complexity of the structural design and the need to ensure structural safety, both rebar bending, tie work and formwork assembly required a high level of technical expertise. During peak construction periods, concrete mixer trucks were constantly in motion to support the concrete pouring operations. After the completion of the foundation structures for the 2 hydroturbine generators and the high-level structures for cable conduits, a gantry crane was installed by the owner for equipment installation within the plant. The Bakaro Hydroelectric Power Plant was designed to house 2 hydroturbine generators with a total installed capacity of 126,000 kilowatts. As the main structures, from the dam, intake, head race tunnel, and power plant to the tail race tunnel, approached completion, every work front accelerated efforts with the goal of completing the project ahead of schedule. After the main structure of the dam was completed, the project was handed over to the client for the installation of electromechanical equipment on the dam body and integration with the control center. The reservoir's maximum water level was set at an elevation of 612 meters above sea level, with a maximum effective storage depth of 10 meters. Upon impoundment, intensive commissioning of the tunnel water flow and power plant machinery was immediately initiated. Following 3 years and 5 months of arduous construction, the Bakaro Hydroelectric Power Plant officially began impoundment on September 15, 1990. The hard work of Retsair Engineering Agency's staff finally bore fruit, with the reservoir filling process completed smoothly and successfully. On December 22, 1990, the Bakaro Power Plant was completed 3 months ahead of schedule and handed over to the client for power generation. The client, Indonesia's state electricity company, held a grand inauguration ceremony at the Bakaro Power Plant to mark the commencement of electricity generation. A formal completion ceremony followed on May 13, 1991, presided over by President General Suharto of Indonesia, who officiated the button-pressing ceremony. This milestone marked the beginning of a new era in energy development for South Sulawesi Province. The entire project was completed and commissioned for power generation 3 months ahead of schedule, thanks to the unwavering dedication of the construction team. This not only demonstrated Retsair Engineering Agency's exceptional engineering skills and construction quality, but also had a profound impact on the industrial and economic development of the region due to the plant's early operation. Retsair Engineering Agency is a highly capable and committed team. In this project, they leveraged internationally recognized technical expertise, outstanding quality, effective construction planning, and operational management. With resilience and determination, they overcame flash floods and wilderness hardships, sacrificing comfort to serve in the overseas engineering market. Their dedication and sincerity won them widespread friendship and respect. The Bakaro Hydroelectric Power Plant is the largest hydroelectric project ever undertaken on Sulawesi Island, and it has had a lasting impact on the province's overall economic development. All Retsair Engineering Agency personnel felt a deep sense of pride in contributing to Indonesia's national development and in working alongside the Indonesian people to promote the country's economic prosperity and progress.